Hello, thank you for clicking on this video. This video I'll be showing compound angles um, and what they are, how to use them and stuff. So let's go. I'll just write out all the formulas right now. So the first one is sine x plus y, where x and y are two different angles. They can be in radians or degrees. In grade 12, you'll be seeing them in radians more than likely. But anyway, it goes as follows. That's my mistake. It goes like this. Sine x multiplied by cos y plus cos x multiplied by sine y. If you have sine x minus y, it's basically the same thing. This is the same, this is the same. The only thing that's different is that it's subtraction now. The next two we're going to go over is cos x plus y, which equals uh, cos x multiplied by cos y minus sine x sine y. If we have cos x minus y, again, the ratios remain the same, but the sign, the operator, changes. And the final one is tan x plus y. This one is a little less common, I feel. But anyway, it goes as follows. Tan x plus tan y over 1 minus tan x tan y. If we have tan x minus y, the ratios remain the same, but the arithmetic operators go as subtraction on top and addition on the bottom. So these are formulas, so someone's already done the math for you. So you just have to apply it, right? So let's try cos 11 pi over 12, right? You can convert that to degrees if you wish, and if you do so, that is 165 degrees. Yeah. So our goal, right? The reason why we're using compound angles or multiple angles, we're gonna try and get a bunch of special angles to add up or subtract to this number, right? Valid angles are obviously any multiple of 45, 30, or 60 plus the boundary angles, so 90, 180, 270, 360. Or, in grade 12, 45 is pi over 4. 60 is equal to pi over 3. 30 degrees is equal to pi over 6. 90 degrees is equal to pi over 2. 180 is equal to pi. 270 degrees is 3 pi over 2, and then 360 degrees is 2 pi. So those are, you're going to want to find a combination of any of these angles to get 165. It can be in multiples of the special angles too. Alright, you remember how I said it can be multiples of the special angles too? So, uh, here's an example of a multiple of special angle you could use. So for this one, we could do 120 degrees plus 45 degrees. you can see here that 120 degrees is just 4 times 30 degrees, right? But we're not gonna use, degrees. So you can just convert that to radians real quick, and that just gives us uh, 2 pi over 3. So we have both our angles now. I'll just write it over here. So now we're going to write cos 2 pi over 3 plus pi over 4. And then you write out the formula right here, right? We're using addition, so we're going to use cos x cos y minus sine x sine y. So cos 2 pi over 3, right? Yeah. And then cos pi over 4 minus sine 2 pi over 3 sine pi over 4. Right? So now these are all special angles, so you can just get the ratio without a calculator. That's kind of the whole point, because special angles are like clean values. You won't get all these like decimals and stuff. You can get exact value really easily. Um, you know, cos pi over 4, so you multiply that by 1 over square root 2, right? Or, what's easier is just write it as square root 2 over 2, which is, they're the same thing. Because 1 over square root 2 is basically saying half of square root 2, which is what square root 2 over 2 is, right? So now you're going to subtract sine 2 pi over 3, which is, I should really have this memorized, but, I'm only human, guys. I'm only human, right? 3 pi over 2, multiply that by square root 2 over 2, right? So now we have 2 minus 6 over 2, right? Yep. And then now we have negative square root 2 minus square root 6 over 2. Right, so that's basically your final answer. If you want to, or if your teacher requires it, you can factor out this negative, right? So then we basically get negative, this becomes positive, because if you multiply it by negative, it should become negative. So then you factor out the negative, and you basically get square root 2 plus square root 6 over 2, right? Don't really need the brackets, I guess, but factor it out, and there's your final answer. You can check it with a calculator too. Here in my textbook, I'll just use another question, because this was cosine, and sine and cosine. Those formulas are not as annoying as tan. So let's try this question. Tan negative 5 pi over 12. Now here's something to remember. The functions tan and sine are negative. No, not negative. They're odd functions. What does that mean? So when tan and sine have a negative angle, those are equal to negative, the negative function. Whereas cos is an even function, so cos negative angle is just the same thing. You can even check it with Desmos. You know what? I might show you right now. Here, if we type it out on Desmos, so we have negative 10x here, negative x right here. Exact same thing. Let's try sine now. Same thing. And now with cos, same line every time. So what does this mean? That basically means this negative sign, we can basically ignore for like the entire question. We just have to add it back to the final answer when we're done. So with that in mind, we can just do tan 5 pi over 12, right? You're welcome to convert that to degrees again, because with degrees it's much easier to visualize, you know, what numbers you need. I don't really understand why we use radians anyway. Isn't degrees kind of precise? Maybe radians, we use radians to be more precise without having to write 10 billion digits. Yeah, maybe that's why. But anyway, this is equal to 75 degrees. Um, so, you know, we could just, for special angles, we could use 45 degrees plus 30 degrees, or, you know, tan pi over 4 plus pi over 6 equals, back up here for the formula, super fucking long. I shouldn't have cursed. I'm sorry if you heard that. Anyway, so tan x, so, you know, tan pi over 4 plus tan pi over 6, 1 minus whatever. You can probably see it anyway. Tan pi over 4, tan pi over 6. Okay, with these, we can easily get the exact value of each of these ratios. So tan pi over 4 is just 1, and then tan pi over 6 is just square root 3 over 3, right? Because, you know, the opposite of the, you know, if I draw the triangle, pi over 6, pi over 3, this is 1, and this is square root 3, so it's equal to 1 over square root 3, but because we don't like radicals in the denominator, we can just rewrite that as square root 3 divided by 3. Same thing. Do you know why? Because if I actually undo it, you know, right? We can rationalize this by multiplying both the top and the bottom by square root 3, because square root 3 multiplied by square root of a number multiplied by itself is basically canceling out the square root, and you just get the original number, and then obviously we had to, you know, multiply the numerator too, so that's why it's square root 3 over 3. Really useful to know. But anyway, if we multiply 1 over, by square root 3 over 3, we just get square root 3 over 3. Right? So, you know, just do the addition and subtraction. So that's 3 over 3 plus, no, I don't want to write it there. 3 over 3 plus square root 3 over 3, right? That just equals 3 plus square root 3 over 3. And then this is just 3 over 3 minus square root 3 over 3 equals 3 minus square root 3 over 3. Right? So with that in mind, we basically just have 3 plus square root 3 over 3 multiplied by 3 over 3 minus square root 3. You know what? Here's a fun drinking game. Take a shot for each time I said 3 in the past 10 seconds. Anyway, yeah. We're doing this step because we're basically doing the division here. A fraction is the same thing as division, right? So these cancel out and we get 3 plus square root 3 over 3 minus square root 3. So you could consider this as the final answer, but remember how I said we don't like radicals in the denominator? So we're going to rationalize it through the same thing, right? So we're going to multiply the top and bottom by 3 plus square root 3 to get rid of that radical sign, right? So if we do the math, you know, multiply this 9 plus 3 times square root 3 minus 3 times square root 3, those cancel out. Negative square root 3 multiplied by square root 3, that gets rid of the negative sign, the square root sign essentially, so that gets us 3, right? So that's, equal to 6, right? So I guess I can just get rid of that. Maybe I should try arrows. Oh no, but anyway. So then we basically take the numerator, multiply those now. So 3 times 3 is 9, right? 3 multiplied by square root 3. That's, you do that twice, right? So that equals, well, I'll show it later, I guess. I don't really know how I'm doing this, but square root 3 times square root 3, that equals 3. So, consolidate all this. We get 12 plus 6 square root 3 divided by 6. And to get our final answer, we just divide everything by 6. So 12 divided by 6, that's 2. And then 6 multiplied by square root 3 divided by 6, that just becomes square root 3, right? Are we done? No. All right. Remember, the original question was a negative angle, and according to this, the answer needs to be negative. So therefore, the final answer is negative 2 plus square root 3. So that's just applying the formulas. I mean, as you can see, it's a very lengthy process, but I mean, I guess it is what it is. But there's this cool question in my textbook that I want to show you. So it goes as this: simplify sine f plus g uh, plus sine f minus g over cos f plus g plus cos f minus g. Keep in mind this isn't just 2 tan f plus, this is just tan f plus g plus tan f minus g. This ain't that. So we're just gonna apply to solve this. First step, we're just gonna convert to the formulas. So this is sine f cos g plus cos f sine g. It's gonna take forever to write this, bro. I'll just put it in brackets to make it look less like a disaster. Sine f cos g minus cos f sine g. Right, check your work. That seems about right. So that's all on top of cos f cos g minus sine f sine g. Oh goodness, how many times I freaking said that, dude? Cos f cos g plus sine f sine g. Okay. Oh my goodness, dude. So much mess. Anyway, we never needed the brackets. So now from here, we can just combine like terms, so, this and this add, so you just get out of here. Same thing with this and this on top. Those just cancel out and get out of here. Now, you combine like terms, we're left with 2 sine f cos g over 2 cos f cos g. These cancel out, and you know, these cancel out too, but where the answer is tan f. But there's this tricky thing that we need to make sure of. The denominators, right? We have these two terms here, cos f and cos g. 2 doesn't matter because that gets out of here. It's a constant. But these need to be stipulated that they are not equal to 0. Otherwise, the entire question, this entire thing would not exist. It would be undefined if it was 0. So we have to stipulate or state the restriction that both of these cannot be 0. Otherwise, the answer wouldn't be tan f. It would just be like undefined. But yeah, that's all I have today. So you know, take a screenshot of my beautiful handwriting, right? There's the formulas right there. But yeah, thank you for watching if you made it this far. Um, and I hope you have a good day, man.